Nanoscience. Nanoscience deals with particles in the range of 1 to 100 nanometers. 1 nanometer is 0.0000000001 meter, or 1 times 10 to the minus 9 meters, or 1 millionth of a meter. A human hair has a thickness of about 30,000 nanometers. Nanoscience involves the creation of structures that may contain anything from a few hundred atoms to millions of atoms. On this scale, the nanoparticles are found to have very different properties from the material in bulk form. A piece of gold looks yellow. If, however, we looked at a nanoparticle of gold which has a size of 50 nanometers, it would look red. By controlling the way in which these nanostructures are put together, it is possible to control properties such as toughness, strength, hardness, electrical conductivity, and color. Nano-sized particles. Particles of nanosize have very high surface areas for their volumes. It is this very high surface area that is partially responsible for some of their unique properties. High surface areas make nanoparticles ideal catalysts for chemical reactions. This area has enormous potential for future development. Creation of nanoparticles. Nanoparticles at present can be created in two ways. In the top-down approach, a large chunk of material is gradually etched away, often chemically, until the correct sized particle remains. This is the technique used, for example, in microelectronics to produce miniature circuits on wafers of silicon. In the bottom-up approach, very small molecular building blocks are used to assemble nanoscale structures. Recently, molecular transistors and other electrical components have been assembled in this way. Moving atoms. It is also possible to move individual atoms across the surface of a particle to produce a new structure. This technique uses a scanning probe microscope to push atoms across the structure. It is now also possible to spray paint atoms as thin layers precisely onto a surface in a controlled way. Fullerene's buckyballs. In 1985, Robert Curl, Harold Kroto and Richard Smalley discovered a new carbon structure. They were conducting an experiment in which a laser beam was fired at a carbon surface. The vaporized carbon was released into a stream of inert helium gas. The carbon atoms condensed to form clusters of C60 molecules. The structure was called Buckminster-Fullerene after the American architect Buckminster Fuller, renowned for his football-like dome constructions. Further experiments have produced other carbon clusters with similar football structures, for example C70, C80 and so on. They have been nicknamed buckyballs. The structures have a size of approximately 1 nanometer and mark the beginnings of nanotechnology. Nanotubes. Chemists have now created nanotubes. These consist of hexagonal cylinders of carbon atoms and can be produced in a similar way to buckyballs using a cobalt catalyst. Nanotubes can be imagined as a sheet of graphite rolled up to form a cylinder. Nanotubes can be closed at each end by half a buckyball. You can also get nanotubes with more than one wall. It is also possible to get buckyballs to fit inside nanotubes like peas in a pod. Certain atoms behave like tiny atomic magnets. If these could be trapped inside the buckyballs and then trapped inside the nanotube, they could act as a data storage device on a nanoscale. This could revolutionize computing. Carbon nanotube sheets. In 2005, the first carbon nanotube sheet was produced. This had incredible strength, conducted electricity, was flexible and transparent. The applications for such a material are endless. Try and think of some. At present, however, the cost of production is prohibitively high. New future techniques will have to be found if the potential of this new technology is to be exploited. Properties of nanotubes. Depending upon their structure, nanotubes can be made to be conducting or non-conducting. They can also be made into semiconductors, which could lead to a new generation of electrical devices. They are very strong, about 100 times stronger than steel, stiff yet elastic when strained, and lightweight. Nanotube technology. Nanotubes are already being used to make miniature electrical components. They are used to make tennis rackets that bend less on impact, improving performance. A plastic nanocomposite is being used to make car bumpers, which are much lighter and more resistant to denting. The potential for nanotube technology is almost limitless. Use the internet to research some potential future uses for nanotubes and buckyballs.